graph absolute value functions. So our goal today is to graph absolute value functions. The parent function for absolute value functions is just the plain old absolute value of x. So if we plug -2 in, we get the absolute value of -2, which is just 2. So over here on our graph, we're going to go to -2, 2, and put a dot. Then here, we plug in -1, so the absolute value of -1 is a positive 1. So on our graph, we're going to go to -1, 1, and put a dot. Then we plug in 0. Absolute value of 0 is 0. So we go to 0, 0. Then the absolute value of 1 is 1. So 1, 1. And the absolute value of 2 is 2. So we go to 2, 2. Then we can draw our graph. It looks just like a V. So that is our parent function. Starts at 0, 0, and then each line has a slope of 1 or -1, and it's shaped like a V. So, for example 1, we are going to graph these two functions and compare the graphs with the graphs of f of x equals the absolute value. So we're going to compare to the parent function. So here we are going to make a table of values. So if we plug 1 in, 1 minus 4 is -3. The absolute value of -3 is positive 3. If we plug 2 in, 2 minus 4 is -2. The absolute value of -2 is a positive 2. If we plug 3 in, 3 minus 4 is -1. Absolute value of -1 is positive 1. 4 minus 4 is 0. Absolute value of 0 is 0. Plug 5 in. 5 minus 4 is 1. The absolute value of 1 is 1. And then we would go through and graph these. So 1 is going to be at 3. 2 is 2. 3 is at 1. 4 is at 0. 5 is at 1. And then we can draw our graph. So this is our parent graph here, the one that was already drawn. And this one is our new graph. So the graph of g of x is 1, 2, 3, 4 units right of our parent graph. Okay, so now we do the same thing here. Absolute value of -2 is 2, plus 3 is 5. Absolute value of -1 is 1, plus 3 is 4. Absolute value of 0 is 0, plus 3 is 3. Absolute value of 1 is 1, plus 3 is 4. Absolute value of 2 is 2, plus 3 is 5. So we are going to graph -2, 5, -1, 4, 0, 3, 1, 4, 2, 5. So we draw our graph. And this one is 1, 2, 3 units above or up from our parent function. So this one, where it's inside the absolute value, moved to the right. So if it's inside the absolute value, it moves left or right. If it's outside the absolute value, it moves up or down. So for example 2, we're doing the same thing. We are graphing the functions and then comparing. The only difference here is we are multiplying instead of adding or subtracting. So we plug in negative 2 here. The absolute value of negative 2 is 2. 2 times negative 2 is negative 4. Absolute value of negative 1 is 1 times negative 2 is negative 2. Absolute value of 0 is 0 times negative 2 is 0. Absolute value of 1 is 1 times negative 2 is negative 2. Absolute value of 2 is 2 times negative 2 is negative 4. So for this one, we go negative 2, negative 4, negative 1, negative 2, 0, 0, 1, negative 2, and 2, negative 4. So it goes down like that. Okay, 4b, we plug in. So the absolute value of negative 4 is 4 times 0.75 is 3. The absolute value of negative 2 is 2 times 0.75 is 0.75 times 2 is 1.5. Absolute value of 0 is 0. 0 times 7.5 is 0. Absolute value of 2 is 2. 2 times 0.75 is 1.5. Absolute value of 4 is 4 times 0.75 is 3. So, going to go on our graph here. Negative 4 is positive 3. 1, 2, 3. Negative 2 is at 1.5. 0, 0. 2 is at 1.5. 4 is at 3. Okay, so there's our graph. The graph of g of x equals negative 2 absolute value of x opens down and is narrower or skinnier than the graph of f of x. So this one looks like that. This one opens down and is smushed. It's a little bit narrower. The graph of g of x equals 0.75 absolute value of x opens up and is wider or flatter than the graph of the absolute value of x. So now we have some checkpoints, so go ahead and pause the video and do those.